Hello and welcome to this new video. Today we're going to solve a simple resistor on voltage sources circuit using Kirchhoff voltage law. Okay, so we are asked to find some currents across the circuit. In this case, we are going to calculate the current across 1 ohm resistor, the current across 3 ohm resistor, and we are going to get the voltage across resistor 2 as well. This voltage, we are going to find it the way they are telling me to do it. Okay, the opposite voltage on the left and the negative voltage on the right. According to Kirchhoff voltage law, we know that the algebraic sum of the voltages across a circuit, around a circuit, equals 0. This means that if I drew a voltage around a mesh, as I'm doing in this case on the left mesh, the voltages across this mesh must be 0. So uh, to do this, first of all, as I did before, I draw a current in a mesh the way I want. In this case, I want clockwise, and on the second mesh, I draw a current the way I desire. In this case, contour clockwise as well. Once I draw these currents, I have to look at the mesh on the left. Okay. Um, this current, taking into account the path of this current, I find a voltage rise due to the voltage source, and then due to this current, I find that I get a voltage drop across 1 ohm resistor as I drew it uh, uh, in the upper side of the circuit. The same I do on the right mesh. Due to the way I drew I2, there is a voltage drop across resistor 2 the way I drew it, and a voltage drop across 3 ohm resistor the way I drew it. To do this, we are going to take into account, okay, when we go around the mesh, we are going to take into account voltage raises as positive and voltage drops as negative. So taking into account this convention, I'm going to begin by drawing the equation of mesh 1. To do this, I'm going to depart from one point, the point on the left you are seeing there. I can go counterclockwise or I can go clockwise. In this case, I'm going to go clockwise the same way I drew the current, and taking into account this, the first I find is a voltage due to the convention I referred previously. I find a voltage rise of 5 volts due to the voltage source. Okay, and then on the 1 ohm resistor, due to the way I drew I1, I see that the polarity is positive on the left, negative on the right. This means that I have a voltage uh, drop uh, according to the way I'm going around the mesh. Then I find a voltage raise due to the 1 volt source. So the addition of these voltages equals 0. Okay, so solving this equation, I find that the current I1 equals 6 amperes. Okay, so uh, to calculate I2 by writing the equations on the right mesh, I'm going to follow the same convention. I'm going to follow the same strategy. I'm going to depart from one point and I'm going to go around until I get to the same point. And the addition of all the voltages across around the mesh equals 0. So I'm going to depart from the lower node. By doing this, I find that I have, according to the convention, I have a voltage drop of 1 volt due to the voltage source. Then I get to the point, to the upper point, which is named X. I'm pointing right now, and following the path, going around clockwise as I did before, I find that I get a 2 volt voltage drop across 2 ohm resistor. Okay, so I get to the point on the right, and then when I continue to go around the mesh the way I established before, I find that I get a voltage drop across 3 ohm register, so I write it with a negative sign. Okay, so -1 due to the voltage drop across the voltage, minus 2 times I2 due to the voltage drop across the 2 ohm resistor, and minus 3 times I2 due to the voltage drop across the 3 ohm resistor. In this case, going around this mesh, I only find voltage drops. So by solving this equation, I get that I2, the current around mesh 2, equals minus 0.2 amperes, or 200 milliamperes. As I was asked to find the current through 1 ohm resistor, this is the same current I want, which I calculated before, and the current across 3 ohm resistor is I2. Okay, so the current across 2 ohm resistor is minus 0.2 ampere. Okay, so uh, I will also ask to find Bx the way it is drawn there. Look that as I drew I2 going around the mesh uh, clockwise, so the voltage across 2 ohm resistor is the same polarity as the voltage Vx. So, okay, so to calculate Vx, what I have to do is to, by Ohm's law, I have to calculate the voltage across 2 ohm resistor, which equals I2 times 2 ohms. Okay, but as I2 yielded negative, so from here I can see that the voltage I'm going to get across 2 ohm resistor, which is Bx, is going to be negative. Okay, the voltage I'm going to get is minus 0.4 volts. Okay, so it's on the opposite way it is drawn in the circuit. So um, what does this mean? This means that the polarity, according to this sign I got from the calculations, the polarity, as I'm going to draw right now, it is going to be opposite to the one that I have in the circuit. Look, now we're going to draw it, okay, with an orange color, okay, that Bx is positive on the right and negative on the left, okay. So as you can see now, look at the circuit. This is the polarity of the 2 ohm resistor, minus on the left, plus on the right, 4 volts, okay. And we're going to draw it. We're going to draw this corresponding voltage in orange, and it could be this way. That's why when they ask me to calculate it as they draw it in the circuit, it yields negative. So now I'm going to perform a simulation by using LTSpice. Okay, I'm going to calculate the current across 1 ohm resistor. Okay, so now you can see that the current yields 6 amperes as we got by means of the calculations. Okay, you can see it on the graphic, you can see it numerically on the lower right. Okay, so let's now find by means of the simulation what is the current across the 2 ohm resistor. Okay, so we cannot see it properly on the graphics, but we can see that the resulting current is minus 200 milliamperes. Okay, so now I'm going to by means of the simulation, I'm going to calculate the voltage difference between the point on the left and the point on the right, which is the way they told me to calculate it. And by doing this, I can get that the voltage difference is minus 0.4 volts